In the previous video, we looked at managing groups of objects. The first thing we did was looked at an array of objects, just creating a simple array and then storing references to our objects inside of that array. It's, if you wanted to draw an analogy, it's the equivalent of a suitcase and just stacking as many of our objects into that suitcase, and we can rummage through that suitcase and find one specific item and begin to work with it. We could even call a method on each item using an iteration statement. We saw how to do that. And as we noted, the simple array is handy, but we found it a bit limiting, mostly because we had to know up front exactly how many items that we were going to put in the suitcase, or rather put into the array. So then we looked at the system.collections classes. Specifically, we looked at the array list. And we noted that this is better because it had some additional methods and some benefits. We could add, remove, we could insert items into the collection and not really worry about figuring out the number that we would need to manage up front in the process. We wouldn't have to figure it out ahead of time. We could add dynamically as we go along, and that container will expand to fit whatever we need. However, the array list was also a bit cumbersome because everything in the collection was saved as type system.object. So when we got it out of that collection, we had to cast it back to the type there so that we could actually use it and do something meaningful with it. And so you have to cast objects coming out of the collection back into the original data type. And the problem was exactly that. It was dangerous because while you could add any type of an object into a collection, it can bite you whenever you try to add different types into the collection, because when we tried to cast a book into an automobile, we got the error message, the exception, when we hit that line of code. Okay, so in this video, we're going to look at our first step to improving that process. And this improvement premiered in .NET 2.0 back in 2005, and it's called generic collections. Now, the word generic can be a little bit confusing because what you're actually doing is specifying a specific data type for your collection, meaning that every item in the collection is guaranteed to be the exact same type. So really what you're doing is you're working with a collection that is generic, and you are going to be the one to pass in the type that makes it specific to a given specific type. Okay, so there's no chance that a book object can wander over and find its way into our automobile collection, or rather our collection, our list of automobiles. So anything that gives us type safety, or remember from yesterday, anything that is strongly typed gives us some degree of confidence in our code. It gives us some assurance that as developers that our code won't break so easily whenever we hand it off to somebody who actually wants to use the application. We're going to find those types of problems where we try to add a book to a collection that can only hold automobiles. We're going to find that at compile time instead of at runtime when our users are using the application. Okay, so what we're looking at here is another example similar to what we were looking at in the previous video. It's a new project called Generic List of Objects. And here we have the automobile class, just like we had last time. There's nothing different about it. Let's close that. And then in our void main, here we're going to create a new generic list. So the proper way to say this is we're going to create a list of automobiles. So it's a list of something. You'll see it defined in help as a list of T. That of T is the magic word that means of any type that you pass in. And the way that you type a pass in to a generic collection, or any type of generic later on, is by using the open and close arrows or brackets or whatever you want to call them. Okay, it's this syntax of the open and the close bracket with the type that we're going to make this specific to. This generic, we're going to turn it into a specific by passing in that type. Okay, so in this case, we have a list of automobiles called inventory, and so we're instantiating it by calling a new list of automobiles. All right, so here we go. Same thing as before. We're creating 5 instances, and the dangers of copy and paste are apparent here because every time I go through this example, I'm going to have to change that. But ultimately, our inventory has an add method. If we were to just take a look at this, I think we might find something interesting. Add, and when I open it up, notice in the IntelliSense that this is of type. It knows that it's a list of automobiles in the IntelliSense. And it knows that when we call the add method that we're specifically looking for an automobile type. Notice automobile item. Underneath that listing, we can see adds an object to the end of the system.collections.generic.list open and close T. Again, that capital T is, you should say, of T, or of a generic type, or of a type. Okay? So let's remove that. So what we can do now with confidence is do a for each through our inventory with confidence that every item in there is going to be an automobile. So there's no casting step like we had previously in our array list. This time, since it's a list of automobiles, we can just go item.print. All right. Similarly, we can call inventory 0, first item, dot year. Now, how is that possible? Well, because it knows that the inventory is a list of automobiles, and it knows that we're calling that bracketed syntax, which means give me an item in this list. Give me the first item because I'm using 0. When I hit the dot, IntelliSense is intelligent enough to know that we're only dealing with a single instance of an automobile, and therefore I can get to any of the given properties of an automobile. All right, so let's run this application just to watch it work. All right, so our oldest car was built in 1976. Everything else looks similar. All right, works great, right? So this is all we would ever need. Well, sort of, but perhaps not exactly. Let's go ahead and talk about the book. So here we have our book, and say now we want to add it to a list because, of course, now our company has expanded beyond automobiles and we're also selling books, right? So how can we make this work? Well, the problem is a generic list is not going to solve that problem. As you can see here, I'm creating a new instance of the book, and now I'm going to try and add that book to inventory, but I get a red squiggly line. I could go ahead and hit F6 or try to hit compile the application, but the problem is the same. The error message is that it has some invalid arguments. In other words, I can't pass something of type book into something that's expecting a type automobile. That's ultimately where the problem resides. And so how are we going to fix this? Well, using a generic list isn't going to fix this specific problem, but generic lists are part of the solution, and we're going to continue to build on that idea. So one last note before we move on. We talked about generics and the syntax for declaring a generic using that bracketed syntax to specify and turn a generic collection into a specific collection. Again, my nomenclature, it's not the official nomenclature. I'm sure there's a better way to state that. But at any rate, the topic of generics is very large. We only looked at one specific implementation of generics, namely generic collections, because that's where, at least at first, generics' most obvious benefit lies. So you could create your own generic objects, and there's some reasons why that might make sense, but we're going to have to reserve that to a much more advanced conversation much later on in our work together. Okay, but if we wanted to ensure that we could add a book to the collection, well, how would we go about doing that? Well, let's talk about abstract classes and interfaces in the next couple of videos. Thank you.